In this video, we're looking at integration by parts. So here we're looking at integrating something that has more than one part. So what we're going to do is start by going back to our product rule. So remember here our d on dx of u multiplied by v. We had u multiplied by dv on dx plus v multiplied by du on dx here. So this is our product rule. And we're going to be working with this in reverse and with just a few slight changes involved. So we're going to be able to use this to evaluate some examples like this. We've got x multiplied by sine of x, x squared multiplied by e to the x, 1 by a natural logarithm of x, e to the x multiplied by sine of x. So if we look at our product rule here, if we're to integrate both sides, here, integral here of our differentiation, we end up with u times v. On our other side, we've got two parts. We know we're adding, so we can just integrate them separately. And here we put this through, and we've got here dx here and dx on 1. We can cancel out these dx's. So we end up with u times v is equal to our integral of u dv plus our integral of v du. And we rearrange this, move this integral of v1 over. We end up here with our integral of u multiplied by dv is equal to u times v minus here our integral of v du. It doesn't make a lot of sense just yet, but when we start to work with our examples, this will start to make some sense. So here, our example, we want to find our integral of x multiplied by cosine of x dx. What we do, we're going to write out our rule here. Integral of u times v dx here is equal to u multiplied by v minus our integral of v du. So what we're going to do is say, well, this is my u. U is equal to x. And then this whole term here becomes my dv. So here dv is equal to cosine of x dx. So we look at that as a whole term there. So if u is equal to x, if I differentiate that, du on dx is therefore 1. If I have du on dx is equal to 1, and I multiply both sides by dx, and dx here. I end up with du, they cancel out, is equal to dx, 1 times dx or just dx. And now on the other side, I know, well, dv is equal to that, and I've got this dx. If I divide both sides by dx here, so dv on dx, these cancel out, is equal to cosine of x. And so this is something we're more used to seeing. Now if I integrate both sides of this, I'm going to be left with v. Here is equal to our integral of cosine of x, which becomes sine of x. And so now when we think about our equation, I've got u here, I've got v here. I need v, I've got that, and du, I've got that here. So here my integral of x multiplied by cosine of x dx is equal to u, which is x here, multiplied by v, which is here sine of x, minus our integral here of v, which is sine of x, du, which is just becomes dx there. So working through with this, I get x multiplied by sine of x, and then here minus, then my integral here sine of x becomes negative cosine of x, and then I put my constant c in. So I end up here x sine of x minus minus becomes plus, cosine of x plus the constant c there. So if we move on to our next question here. Here I've got x multiplied by e to the x dx here. So x becomes my u. U is equal to x. I continue it down. Du on dx is equal to 1. Therefore, du is equal to dx. And then here, this becomes here my dv. So dv is equal to e to the power of x dx. So dv on dx is equal to e to the power of x. If I integrate both sides here, v is equal to e to the power of x. So here our integral of x multiplied by e to the power of x dx. So that's my u and that's my dv. Is equal to my u, which here is x, multiplied by here v, which is e to the x, minus the integral here of our v, e to the power of x, multiplied by dx, which becomes du here. Du, which becomes dx here. So I end up with x e to the power of x minus here e to the power of x plus the constant c. So moving on to our next question, we're going to be doing the same sort of thing, but we're just going to take a little bit of a step before it. So here I've got integrating x times our natural logarithm of x dx. I'll just write here, I'm integrating natural logarithm of x multiplied by x dx. So natural logarithm of x is my u, x dx becomes my dv here. So here I've got u is equal to natural logarithm of x. du on dx therefore becomes 1 on x here. So here du is equal to 1 on x multiplied by dx, or we could just write it as here dx on x. So for my other part here, dv is equal to x dx. Dividing both sides by dx, dv on dx is therefore equal to x. Integrating both sides here, v is equal to a half x squared. So now when we think through our equation here, we've got our u, we've got our v. We've got our v here, and we know du is equal to 1 on x multiplied by dx there. So here our integral of natural logarithm of x multiplied by x dx here becomes our u is natural logarithm of x multiplied by here our v, which is a half x squared, minus our integral here of our v, a half x squared, times our du, times 1 on x dx. So if we work this through a little bit here, I'm ending up with natural logarithm of x multiplied by x squared on 2. So our half x squared goes at the top and the 2 goes at the bottom. Minus, here if I put this together, I've got 1x squared at the top on 2 for our half x squared, and multiplied by 1 on x. So an x goes here at the bottom. I can cancel out that x and I can cancel out the squared. I'm minusing 1 and I've got x to the power of 1 there, dx. So here I've got x squared natural logarithm of x on 2, minus here our integral of x on 2 dx, or a half x dx. So this becomes x squared natural logarithm of x on 2, minus here x squared on 2 times 2 is 4, plus the constant c there. So if we move on to our next example here, I've got here x multiplied by the square root of 1 plus x dx. So here I've got u. U is equal to x. du on dx is therefore equal to 1. du is equal to dx. And then here, dv. So here I've got my dv is equal to 1 plus x to the power of a half dx. So dv on dx here is 1 plus x to the power of a half. Integrating both sides here, v is therefore equal to 1 plus x to the power of 3 on 2 divided by 3 on 2. So here our 2 goes up the top, we're going to end up with 1 plus x to the power of 3 on 2 on 3. So now I've got my u, I've got my du, I've got dv, I've got v. So here, my integral here of u dv is equal to u multiplied by v minus our integral of v multiplied by du. So here that was my u. So here I've got u is equal to x multiplied by v is this over here. 1 plus x to the power of 3 on 2 on 3 minus our integral of v 1 plus x to the power of 3 on 2 on 3 multiplied by du becomes dx there. So we keep working through this, we're going to end up here with 2x 1 plus x to the power of 3 on 2 on 3 minus. So here we're going to go through this, and this is the same as 2/3 out the front here. So here we're going to end up with 3 on our 1 plus x to the power of 3 on 2 gets 1 added to it, so we get 5 on 2. And here we've got 2/3 here, or 2 on 3, and here we're going to, at the bottom, multiply by this 5 on 2 here, plus our constant c. So here we get 2x, and we've got 1 plus x to the power of 3 on 2 on 3, minus here we've got 1 plus x to the power of 5 on 2, and then here our 2 moves up, so that becomes 4, and 3 times 5 is 15, plus our constant c. So we look at these things here, we can work through all of this a bit further with our bits and pieces, but we might leave it at this point here so we can see what we've been doing. If we move on to our next one, we've got 2 examples here. You notice for some of these I've chosen this to be my u, and some of these I've chosen this to be my u, depending what we're going to do. So if we look at x multiplied by sine of x, we can say here, well, our dv here is equal to x. We go through this here, we get v squared, u is equal to that, and we can work through with that. And we end up with something that's not very nice to deal with. Our other choice is to choose here our differential v here is sine of x. Working through this, we get v is equal to negative cosine of x, u is equal to x, and so here our du and dx is equal to 1. Working through our rule, we end up with something, this term is a lot nicer to deal with than this term here. And we have some rules that we follow that helps us to choose which way we're going to select our u and our dv on dx, here, or dv. So our rule of thumb, we call it our ADE rule. And first we look at here, what is going to be used for our u. If we have any logarithmic functions, natural logarithm of x, log of x, anything there, that is our first option to be u. If there aren't any logarithmic functions, then we choose any of our inverse trigonometric functions. If we don't have any logarithmic or inverse trigonometric functions, then our algebraic functions go next. So these are our next options here for our u. Then if there's none of those, then our trigonometric functions, and then finally our exponential functions. And so here our dv is whatever comes last in that list. So we choose our u first. So ADE, we say log, inverse trig, algebraic, trig, exponential. So here, if we look at this example here, if we consider here x times cosine of x dx. Using our ADE rule, we have this no logarithmic terms, no inverse trig. Algebraic is our first one. So here, x will be our u. So u is equal to x, du on dx is equal to 1, du is equal to dx there. And here, dv is equal to cosine of x multiplied by dx. So dv on dx is equal to cosine of x. Integrating both sides, v is equal to sine of x. So now working through with this, we get here our integral here becomes our ux multiplied by v sine of x minus our integral here of sine of x dx. So x sine of x minus negative cosine of x plus our constant c. X sine of x plus cosine of x plus our constant c.